welcome back to more Universe Sandbox. In the last episode, we destroyed Jupiter in some creative ways, some unintentional. Most of them were unintentional. Either way, still looking at some of these solar system with no sun, planets between the Earth and the Moon, yeah, blah blah blah. I'll show this one real quick. So you can actually fit every planet in our solar system between the Earth and the Moon. Here's Earth, and here is our Moon. And you can actually, this is the legitimate distance at which the Moon is from the Earth, and you can actually fit every planet between them. Of course, all their velocities are halted here, so, well, I guess Jupiter's rings weren't, but it's pretty neat. I wish I could, well, obviously I know what's going to happen if I enable all the velocities. Actually, for fun, let's just explode Jupiter. There we go. Now go. Whoa, what happened? Okay. I think I had it going too fast. Yeah, I think everything's locked in place, though. So all we did there was just annihilate Jupiter. As you do. And we turned the Earth into a molten fireball. It's definitely going too quick to even check. Surface temperature of 1800 degrees Celsius. You know, just uninhabitable things. I don't think that Venus and Mars, or Venus, Mercury, and Mars are doing any better. No, they ain't. Alright, whatever. Let's see. Core. I wonder what these are. Tidally heated habitable moon. Interesting. Milky Way, tidally locked Earth. Already looked at that. The Milky Way and Andromeda galaxy collision. Yeah, that's happening in a few billion years. Let's see. About 4 billion years from now, our Milky Way galaxy will collide with the nearby Andromeda galaxy. This collision, the result of the mutual gravitational attraction between the stars, planets, and other matter that make up both galaxies, will produce a single merged galaxy. It is unlikely that any stars in the galaxies will actually collide, although some stars will likely be ejected from the combined galaxy during the merge. Yeah, so this is pretty cool. It's our galaxy merging with a much larger Andromeda galaxy. And you know what's crazy is that there are billions of stars, millions or billions of stars in both of these galaxies. And you would think, oh man, well surely one of them will hit another star or something like that. But it is beyond insane just how it would be like, you know, how do I phrase this? I don't know. It would be like, imagine you have a volleyball net, and you have one grain of sand to throw at the volleyball net in hopes of hitting one of the pieces of net, like one of the strings of the net. You would have to be, just insanely lucky. And that's kind of what you're dealing with here. Let's see. Central black hole in the middle. I don't know if I don't know what the central black hole in the middle of Andromeda galaxy is, but I would assume it's larger. I would assume it's larger than Sagittarius A. I could be wrong. I don't know. Let's see. Our local group. The local group includes the Milky Way and its nearest galactic neighbors. The group includes large spiral galaxies, the Milky Way, Andromeda, and Triangulum, as well as dozens of smaller satellite galaxies. The simulation features 19 of over 60 galaxies that have been identified as members of the local group. Whoa. Sagittarius dwarf spheroidal. Or orbit? We need to turn those off. Sextans B, Leo 1, Sextans A, or Leo I guess. What is this? WLM. There's the Milky Way. Wonder where Andromeda is then. It's behind me? Fornax dwarf. Yeah, the Milky Way is definitely the big dog here, huh? There's Sagittarius A star. Look at it. I don't think it's going to let me zoom in far enough to see it in this simulation. Ah, close. It. Whoa! Hello? Sagittarius A star. Oh, there it is. It did let me zoom into it. Yep, so here's the black hole that's in the center of our galaxy. That's pretty neat. I wonder if all of these, yeah, so all of these do have a black hole, which I guess makes sense. They have to have a, they've got to have a central black hole in order to, you know, something has to be in the center. Something has to be in the center of every galaxy in order to hold it together. In order to give all these stars, there has to be something in the middle to make it a galaxy. There has to be something holding it all together. You know, I guess. I don't know. I'm assuming. What else do we have? Total solar eclipse on August 21st, 2017. Close up. Ooh. I remember getting to see this. Solar eclipse occurs when the moon passes between the sun and the earth and partially or fully blocks the disk of the sun. When it completely blocks the sun, it is a total solar eclipse. Yep, there it is. I think we've already missed most of... Actually, have we? Which way is the moon going? Oh, it's already over. I think it's already over. Yeah, it is. Time's going by pretty quick. Hang on, let me restart this one. See, I think it passed like through here or something. You can see it right here, yeah. And of course, being in Kentucky right here, I'm about right here. So I think we got like a 90% total eclipse. Like we got a really good one to see. We got to watch it and it was really cool. A binary pulsar, that just sounds science fictional. Oh god. This is timed slowed down to 14 milliseconds a second. Pulsars are crazy. Let's go to real time. This is real time. Man, that just seems insane to fathom. I don't know if what I created in the last episode out of Jupiter was a pulsar now. Doesn't quite look like it. It's also crazy that they can share a barycenter like this. It just seems impossible. Did it even like have a description? No, it didn't. It had no information to go with it at all. Kind of creepy. Earth and a sphere of moons. Whoa. Yeah, I was about to say I don't think this is going to be stable, but I wasn't going to say anything because I thought maybe the guy that worked on it did some crazy stuff, but yeah, no. For a minute there, though, it was cool. I would imagine that if such a stable orbit could exist, that the tidal forces would completely destroy the planet and Earth would just be annihilated. But Earth and 75 orbiting moons with upward motion. What in the heck? In this simulation, 75 moons are placed around the Earth. The moons interact gravitationally with each other. I was watching that. And with the Earth. Moons that pass close to the Earth are torn apart by tidal forces. Others collide with each other or crash into Earth's surface. Well, I mean, look at these orbits. Of course, that's not going to stay. Look, there's nothing stable about this. Looks like a fucking kid took a box of crayons and just drew circles all over the galaxy. Look at this orbit. It's just an L. We'll run this for a few minutes, and I guarantee. Well, not look. It'll come to pass. There won't be anything left. If even one of these moons remains having a stable orbit with the Earth, I will be very surprised. Look at them. They don't know what to do. I'm genuinely surprised they haven't all been flung out yet. Woo! Come on. Come on. This is hard to watch, I know, but I'm just trying to speed it up. Oh god, it looks like it's just nightmare fuel, isn't it? We're going at 10 months a second. I'm surprised the game can actually simulate such a thing, to be honest with you. Let's slow it back down. Alright, we've had enough of this. That's enough, that's enough, that's enough, that's enough. That's enough. Alright, let's go back to Earth. That's not the Earth. That is the Earth. Okay, so out of all of these, it looks like 3 moons are still in orbit around the Earth. This one, right here, Ones, and this one here, which I can't even find. Yeah, Dask, and I think it's just those 2. I don't think. What is this? Hang on. What is this center point here? What? It's like there's something. It's like there's something right here in the middle of all of this that they're all flying away from. And I don't know what the hell it is. What a mess. What a mess. I mean, I'm sure if I turned off orbits, there's no way I could find the Earth again. You can kind of see all of them. Whoa. Hey, buddy. Now you can kind of see them. You know what? Just for the hell of it, just because I like doing this, let's add Alpha Centauri. Boop. Now watch as they all begin flying towards the sun. I think. Or not. Are they even moving? I think there's too many of them. I think there's too many in the game. Hang on. Maybe Alpha Centauri doesn't pack enough punch. We need a bigger star. We need something that can actually. Something huge. Now go. Oh, it's not even doing anything. I think there's just too much. There's too much for the game to simulate. There's like one thing. Yeah, the Earth. I think we're breaking the game. Like this is just a mess. All right. I'll stop. It's gotta be painful. Collisions. Mars collision. I'm not interested in most of these. Wolf and Earth. Jupiter and Earth. Well, we know who. These are all just going to be losses. Expositions. Supernova in the galaxy. Earth exploding. I don't want to explode. Small system, random planetary systems. Jupiter solar system. Earth and early moon. The side of the moon that is closest to the Earth experiences a larger gravitational attraction than the side furthest from Earth. The closer the moon is to the Earth, the greater the difference becomes between these two forces. The moon stretches along the direction towards the Earth due to this tidal force. Large objects that orbit too close to the Earth inside its Roche limit, can be torn apart by tidal forces. In this simulation, the moon orbits within the Earth's Roche limit and begins to break apart within minutes, sending fragments flying into the Earth. This Earth and moon have been given very high temperatures of almost 5,000 degrees Celsius to represent much younger versions of our planet and moon, still warm from the heat of their formation. Yep. Everything's got a gravitational limit, and if it gets too close, they just start tearing each other apart. Although, I think that this kind of flung the moon out, didn't it? Or was it the collision itself that did that, to the point to where the moon was in a stable orbit? I'm not sure. Whee! Of course, those fragments will probably either be consumed by the moon itself or they'll fall to Earth eventually. Not sure. Look at that smoke cloud. Alright. I don't really know what to do. I'm kind of at a loss. The Earth at 1 million degrees Celsius. But why? It's gone. Just like that. Alright, hang on. No. Slow the time down. Heat the Earth to this temperature and it will vaporize completely, leaving only a rapidly cooling and expanding cloud of escaping gas and plasma. Yeah. We didn't even get to see it. That's how fast it happened. What about 100,000 degrees Celsius? 100,000 degrees Celsius is the temperature at the top of the sun's chromosphere, the layer below the corona. Heat the Earth to this temperature and it will vaporize completely. Okay, so yeah, same thing, only it takes a little longer to vaporize, apparently. Watch as the Earth explodes. Or not. It's cooling off slowly, but is it not gonna vaporize? Nope, it's cooling down. Yeah, look, now it's just a chunk of charcoal. Poor Earth. What if we do that? Is 150,000 degrees Celsius enough or not? It really does cool down fast, doesn't it? What about 200? 2,000, 20,000, 200,000. Yeah, it just cools down instantly. $5,000, 500,000. Did that vaporize it? I don't think that vaporized it. I think that nope, it didn't. Of course, now look how small the Earth is. It's half as big as it normally is in radius and only a tenth of its normal size. If I were to put the moon here next to the Earth, it would actually be bigger than the planet itself, I believe. I don't actually know. I don't know where to find the moon. Where are moons? Black holes, galaxies, objects, moons. Here we go. Where's our moon? Here it is. Yeah, see, look. At this point, our own moon is quite large compared to our planet Earth. And they share a berry center. Isn't that awesome? Look. Or, don't they? Definitely looks like they have a berry center. Yeah, they do. I think something's wrong with our planet. There we go. Yeah, you can see the barycenter now. See how the Earth kind of went like that, and then now it's curving. It's making like a loop. I'm not finished with you. Hang on. 300,000. Whack. Oh, that destroyed. Okay, that was enough. 300,000 was the number we were looking for, folks. 300,000. And now our moon will fly off tangent to its previous direction, forever destined to be lost in the vast, expansive darkness of space. Actually, it's probably not even going. No, it is going. And it will fly like that forever until it is eventually captured by something else, or more likely, just turns into an ice ball and just sits in space forever. Black hole and sun. Resisting the urge to sing a song. In the simulation, the sun orbits a black hole that is 10,000 times more massive than itself. The sun's orbit is very eccentric, and it takes it within the black hole's Roche limit. At this point, the tidal forces on the sun become strong enough to rip it apart. Some of the material that used to be the sun continues to orbit the black hole, while the rest is thrown out into space. This entire system, the black hole and the sun's eccentric orbit, would fit inside the orbit of Mercury in our own solar system. Really? That's kind of crazy. You can actually see the mass of our sun being depleted there. Right now it's down to 40% of its own mass, so it's being eaten apart by this black hole every time it comes within its Roche limit, which I guess the Roche limit is probably all the way out there, not just at the perigee of its orbit, but I could be wrong. No. Surface temperature is falling. And rising. Yeah, okay, I think the sun may have actually... So I think the sun... I don't know how accurate these simulations are, because it seems like sometimes they just stop after a while. But then if you orbit it long enough, the sun might just disappear. Although it doesn't seem like it. Whee! Whee! Alright, I think the sun... Up! Oh, there it goes. Bye, sun. How fortunate that this black hole was nice enough to fling our sun out into space. Our sun survives, although it is nowhere near as massive as it normally was. I'm curious what its habitable zone looks like now. It's got to be a lot smaller, right? It has to be smaller. If I were to add the Earth, I wonder if it would be if it would still be one astronomical unit away. We really need to slow that down. Of course, it doesn't tell me because I would have to delete that black hole real quick. Hang on. That's gone. So now the black hole, not the black hole's gone. This new version of our sun should be the dominant body. It didn't reset the thing. Okay, whatever. 0.668. 0.668. This doesn't help me. I can't tell. I guess we could just eyeball it. Hello. Alright, so does the sun look any smaller than normal? What's your orbit? 1 month? Holy fudge. Yeah, the sun is definitely smaller. We are definitely closer. Yeah, look at that. Our semi-major axis is, whoa, 0.17? That's crazy. Oh, excuse me. Good Lord. We're 83% closer to the sun as far as distance is concerned right now than normal. 0.17. Dang. We are really, really close to where I bet the radiation would, if it still has the same amount of solar radiation. Yeah, oh yeah, you can actually tell. Look at this. Look at how dim this side of the planet actually is now. We're not getting anywhere near as much sunlight. It's like if this were, canon, our sun would just be like a dim red glow. I'm curious. Hang on. Let's move this. Let's move this to where it's supposed to be. This is where we're supposed to be whilst in orbit around our sun. Look how far away we are. We would be getting almost no light at all at this point. And the surface temperature would plummet. Like, the planet would turn into an ice ball. See the temperature drop? I'll put it in Fahrenheit. I'm just going to assume that from this distance, look how small our sun is. That black hole destroyed our sun. And we are not in a... Okay, we are in a... Okay. Apparently, we're in a very eccentric orbit, which I didn't expect. Why? Why doesn't anything work around here? Damn it. What? Oh my god. 1. Jesus. There. Okay. Now it's art. I just wanted to see if our Earth was still the same distance from our sun after our sun got flung out of its own orbit around that black hole. That black hole sucked like 90% of our sun's mass out of it. I'm curious as to just how cold the planet will get. -70. Yeah, it's just going to keep... The Earth will become a snowball. Yeah, that's insane. We could not survive. Yep, there's the Earth. But, like I said, if we were, it was 0.17. Yeah. This is where the habitable zone is now. So, by this logic, if you run this for a hot minute. Wow. Damn. Calm down, Earth. Now, what's the temperature at? -27. 24. Okay, it's not getting any warmer than that, but it should. That's still habitable, though. I know it sounds crazy, but we could technically survive at -20 degrees Celsius. I mean, that's only -14 degrees. We have temperatures like that now on the planet. It's cold as hell, don't get me wrong. I guess it would have to be even closer, though, at this point. Like maybe 0.1. Just get it even closer to the sun. And then let it run for a minute. Oh, wow. Now it's heating up like crazy. Okay, this simulation is very unforgiving. Because this is too hot. We couldn't survive on this. That's 150 degrees, yeah. Well, you know what? The game can't make up its mind. Oh, not that. Oh, God. We'd be dead within a second. 0.14? Maybe? No, still too hot. All right. Well, you know what? I tried. Fun. That was a fun. What do you call it? Brain theory? No, it's not. What's it called when you like like a thought problem or something like that. I don't know. Just Charikio and its rings. Charikio. Oh, Chariklo. Chariklo is the largest known centaur, a class of objects orbiting near the outer planets that have characteristics of both asteroids and comets. In June of 2013, it passed in front of a bright star, an event known as an occultation, which I guess is a synonym for occlusion, or to occlude, to like, cover. To everyone's surprise, there was clear evidence for not just one, but two rings orbiting Chariklo. I want to try to get that right. This is the only non-planet object in our solar system known to have rings. This object is fascinating in its own right, and the discovery of its rings is a great example of the clever methods scientists use to learn more about our universe. How big are you? Oh, you're not very big at all. Let's compare you to our moon. Oh, yeah. This thing is only 6% as large as our moon. Our moon would swallow this thing. It's pretty neat, though. I wonder how far away from the sun it really is. Like if it were placed accurately around the sun. Does it actually tell us that? Or does it actually list off the... No, it doesn't. It doesn't lift... It will not show the orbital parameters, I guess, because there's no sun. So it can't provide that information. But I am curious, just for funsies, just to compare it in size to our moon. Moon. Oh yeah, look at the size difference. Oh, and we placed it well within the Roche limit, and now it's destroyed. Okay. Well, hey. It happens. Pluto and Moon. Oh wait, no, I thought it was gonna be Pluto and our moon, which would be just as cool. Hang on, let me actually replace Charon with our moon, just to give you an idea of how much larger than Pluto our moon is. Let's see, we'll do it about right there. What? Why are you all the way over there for, you jerk? Let's do it like this. I think I can potentially make this work, maybe. Oh god. Okay, I think I'm playing a dangerous game now. There we go. Still not quite right, and the camera does not want to cooperate with me at all. That's okay, hang on, that's not right at all. But just to give you an idea, like seriously, our moon is gargantuan compared to a lot of the other moons in our system, and even to some planets. Like, here's Pluto, okay? Alright, now here is our moon in comparison to Pluto. And they're going to collide because I put them too close, obviously, but like just to give you an idea, our moon wins in that battle. Our moon, stop. We have our moon, and we have Pluto. If you look at the numbers, Pluto has a mass of basically 1% of the Earth. It's insane, okay? This planet, quote-unquote planet, dwarf planet, whatever you want to call it, is 1% as large as Earth as far as mass. Now, as far in diameter, it's 27% as big. So it's a quarter the size of Earth as far as ground you can walk on. Whereas, oh wait a minute, I was looking at the moon. Damn it. Here we go. Pluto's even more humiliating. The Pluto is not even one. It is barely 1/5% as massive as the Earth, and it only has 18% as much radius. Which, admittedly, when you think about it, as far as surface to walk on goes, Pluto is close to what we have right now on the Earth. I think it's probably about 10% short or something like that. But Pluto has no water, and the Earth has so much water that, you know, it's not really surface that we can walk on. The moon, on the other hand, actually has almost exactly as much surface area to walk on as we do here on Earth itself. It just doesn't have any lakes or oceans or anything like that. Oceans really would be the big one. When you think about it, you're thinking, oh, well, the moon, you know, the moon's only 1/4 of the size of Earth. We couldn't ever colonize it and move everyone there. Actually, we could. We really could. It's just the lack of oceans would cause a problem. It would be water that we're missing out on. But as far as like surface area, as far as like if you shoved every continent on our planet together that we all live on and walk on every day, you could fit them all on the face of the moon. Like, you know, China, United States, Africa, Antarctica, Russia, Europe, Australia, South America. Like, you could really, it would be a surprisingly close fit. That's a pretty neat tidbit of info. And again, they're going to collide with each other because I put them far too close together. Pluto's going to try to orbit just a little bit, but I guarantee you I put them far too close together. Or maybe I didn't. Is this actually stable? Here's all the fragments from earlier. Kind of wish it didn't show those, but are they really going to orbit? Damn. I guess the moon's Roche limit isn't that crazy. Or large. I mean, I could lower. If I do position lock 0 velocity, no. I'm curious as to what that does. No. There is a way to halt velocities, but I don't know what it is. Orbital period. I could lower its speed, right? Yeah, there we go. That's one way of making it happen. Kabloom! Well, a little anticlimactic the way that the moon just kind of ate it, but it happens. Alright. Well, that seems like a good stopping point. I had another 30 or so minutes of just kind of talking and playing around and stuff like that. It was neat. I had fun. I might record another episode or two of this. Who knows? Either way, hope you learned something. Thanks for watching.